Hello, everyone. Welcome to this monthly webinar on the Southwest drought conditions and resources. My name is Joel Lisenby. I'm the Regional Drought Information Coordinator for the Intermountain West Drought Information System and Drought Early Warning System. I'm also with NIDIS, which is the National Integrated Drought Information System. If you don't know much about NIDIS, go ahead and check us out at drought.gov. I'm also with the series group at the University of Colorado. For those of you that are unfamiliar with this webinar series, we usually try to keep these briefings short to about half an hour and also pretty casual. We hope that you feel comfortable asking questions for our two presenters today. We're going to be focusing on some Great Salt Lake issues and some drought conditions across the West. These monthly 30-minute briefings began during the 2020 Southwest drought as part of the Southwest Drought Learning Network's drought monitoring and reporting team. And we plan to continue doing these for as long as the area is experiencing exceptional to extreme drought across the Southwest. We have had some improvement, which Peter's going to tell us about in a minute, but we're still seeing some extreme drought conditions. And so we're going to keep going with these. I'd also like to acknowledge Emily Elias, the director of the USDA Southwest Climate Hub, and also Curtis Riganti from the National Drought Mitigation Center at the University of Nebraska-Lincoln as primary co-organizers for these webinars. The Drought Learning Network aims to support peer-to-peer learning by linking climate service providers with resource managers and resource managers with each other to increase landscape and community resilience in current and future droughts. Before I begin the webinar, I would like to acknowledge that the land that each of us is on today is the ancestral and tribal land of indigenous cultures, and I personally pay my respect to the elders and chiefs, both past and present, of those cultures. Wherever you are across the country tuning into this webinar. And I also welcome all tribal and indigenous peoples who are joining this webinar with us today. Also, just some quick logistics before we get started. This webinar is being recorded, and all of you as attendees are automatically muted and your cameras are off. If you would like to ask questions at any time throughout the webinar, go ahead and type that into the questions box within the GoToWebinar control panel. And following both presentations, the questions will be moderated by Emily Elias from the Southwest Climate Hub of the USDA. Now I'm honored to be able to introduce our two presenters for today. First is Peter Goebel. Peter is a climatologist and water availability specialist at the Colorado State University. Peter is involved in a mix of climate research and climate service activities. His research centers on around soil moisture, and his role I'm reading this introduction. I skipped the line. My apologies. His research centers around soil moisture's role both as an indicator and a predictor of drought. He regularly gives presentations on climate change and climate variability to state and municipal government agencies, farmers, water use, the media, and other interested groups around Colorado. And he's actually quite expert at that. I'm really glad that Peter's here today. Peter's also heavily involved in community collaborative Rain, Hail, and Snow Network, or COCO-RAWS, an international citizen science organization focused on collecting backyard precipitation observations. Immediately following Peter, we're going to be hearing from Christine Rumsey, a hydrologist with the USGS Water Science Center in Salt Lake City, Utah. Since joining the USGS in 2014, she has worked on the Great Salt Lake, where she coordinates monitoring and helps build understanding of water quality, nutrient cycles, and changing salinity. So a huge thank you to both Peter and Christine for joining us today. I'm going to pass the presenter permission over to Peter and we'll get started.
Okay, let's see. Can you see my screen in presenter mode?
Yes, sir. We can see it. We can see it well. Go ahead.
All right. Thank you so much, Joel, and thank you to NIDIS for the invitation and introduction. I'm going to be going over some of the drought and climate conditions we've seen across the Southwest U.S. in recent months. For this talk, I'll be going over, this is kind of the roadmap, I'll be going over current drought conditions briefly. We'll contextualize those conditions by looking at short and long-term weather, and then we'll be looking at how that's influenced our water supply, and then we'll get into what we're seeing in terms of an outlook for the fall and the winter. So that's a lot for 10 to 15 minutes. So just keep in mind that we'll be painting with very broad strokes and local conditions may vary. The picture in the background is a picture I took last November of McPhee Reservoir in southwest Colorado, where you can see the bathtub ring around the reservoir showing where the water is and where the water has been in the past. All right, so Joel showed a map like this earlier, and Joel's map was arguably better. I apologize that the eastern half of New Mexico is cut off here, but there's quite a bit of drought in eastern New Mexico as well. But we are seeing throughout the southwest US that much of the region is currently covered by droughts. So at least with this Intermountain West map, we're looking at 94.3% of the map is showing abnormally dry conditions or drought conditions, with 68% showing D1 or worse. And we even see pockets of extreme or exceptional drought, such as in Utah and in the far northeast corner of Colorado. And we're going to see throughout this talk that this is really balancing short-term conditions versus long-term conditions, where the region really has some long-term water supply concerns. But in some of these areas showing less drought, we have seen more advantageous conditions recently, with some anomalously wet weeks of weather throughout the monsoon season. This is showing a map of how the US Drought Monitor depiction has changed throughout the course of the last 24 weeks. So we're looking at almost 6 months or half a year there, but just a little shy. You can see this goes back to March 22nd of 2022. And there are some pockets of significant improvement. So we had some wet weather in the spring in northern Wyoming. That's where we've seen conditions change as much as 3 to 4 classes in terms of improvement. And then we've also seen some improvements throughout eastern Arizona, western New Mexico, and southern and southeast Colorado in the headwaters of the Rio Grande and Arkansas River basins. And some of those changes have been as much as 3-class improvements based on precipitation in recent months as well. So now we can kind of contextualize how we got there in terms of weather. And I'm going to start with some longer term views of things. So we're going to start with looking at some long-term temperature time series and precipitation time series. And this is showing the upper Colorado River Basin. I can speak to the lower Colorado River Basin a bit as well, but we're seeing that this, at least through our long-term record going back to 1895, has been the 9th warmest water year on record through August. So the water year starts October 1st and goes through September 30th. It's just like a calendar year, except phase shifted in order to kind of better capture the cycle of building up our water resources and water supplies through the cold season, seeing all that runoff, and then through the water usage season in the summer and early fall. But you know, even with it being the 9th warmest water year through August on record going back to 1895, we also see that there's 1, 2, 3, 4, 5 water years within the last 11 or 12 years that have been warmer. So if we look at the last roughly decade, we can see that this the temperatures we've experienced this water year fall right within the recent distribution of observations. And this warming trend is important for the Southwest region because if we have warmer temperatures, that increases evaporative demand, or essentially the effective thirst of the atmosphere for water vapor. What that ultimately means is that the precipitation we do receive disappears more quickly. So a warmer future is a drier future in terms of water supplies, all else being equal. If there were a commensurate bump in precipitation, that could be a different story. This is a look at water year to date precipitation for the upper Colorado River Basin. And the lower Colorado River Basin is similar, where we've seen 3 drier than normal years in a row, and the last 4 out of 5 are drier than normal. The lower Colorado River Basin is a little bit closer to normal because the good monsoonal moisture has really helped out with some of these numbers, but it's still lower than our historical average looking at the water year to date due to drier conditions in the winter and particularly the spring in the lower Colorado River Basin. And this is really a big part of the story, that 4 of our 5 last water years have been below normal. Thank goodness for 2019, but even with 2019 mixed in there, this has really hurt our water supplies in the region. All right, this is a look at recent moisture, just going back to May through August 2022 precipitation percentiles. And this just shows some of the short-term relief that we've seen that's led to improvements on the drought map. It's also arguably helped with the fire season, where the wildfires are certainly raging further to the west in areas like California that have been drier, but in areas like Arizona and New Mexico, prospects have been better recently. We did see some huge wildfires in New Mexico back in the spring, but things have improved with the recent moisture. And some of this recent moisture, as I'll show in a couple slides, also has improved our soil moisture situation. All right, but when we look at groundwater, so this isn't looking at root zone soil moisture quite yet. That'll be the next slide. But this is a depiction of groundwater over the contiguous US from the NASA GRACE satellite, which is measuring perturbations, I believe, in the Earth's gravity, which can be used as a proxy for the groundwater. And we see that there are large areas in the Southwest US that are showing below 5th or even below 2nd percentile groundwater. We can see a lot of this throughout central Utah in areas like the Wasatch Range and the Uinta Range, as well as parts of the high country of Colorado and northeast Colorado. So still some long-term deficits as shown in the groundwater, but we do see some areas of improvement as well in western New Mexico. And then if we look at root zone soil moisture, this is more of a shallow layer. We see a similar pattern, but overall it actually looks a little bit better when we look at a more shallow layer because the more recent precipitation matters more. Another thing that I'll say about this soil moisture map is, as far as modeled soil moisture maps go, this one shows one of the more bearish depictions for the Southwest US, where some soil moisture models are actually showing things a little bit better, particularly in Colorado and Utah. All right, and then we can look at vegetative health. So this is another satellite-derived product where we're basically looking at the ability of local vegetation to absorb near-infrared light, and where it's absorbing that light well, it's greener and healthier, and where it's not absorbing it as well, it tends to be drier. And we can see moderate to severe drought condition across much of the Southwest US, particularly into California and Nevada, but we also see some of those areas where we've seen better precipitation in recent months actually showing near normal, if not unusually moist conditions. So that's a change from what we've seen at this time of year in some recent years. All right, so now in terms of water supply, we're going to back this story up just a little bit to the spring to contextualize things like stream flow and reservoir storage. This is a map showing across the Southwest US what our peak water year peak snow water equivalent measurements were from the snowpack telemetry network in terms of a % of normal, so with reference to this 1991 through 2020 period. And you can see that we're largely in the 70 to 90% of normal range. There are some sites with a little bit better snowpack, but we're on the lower end of normal, which helped contribute to below normal stream flows in the coming runoff season, where here we're seeing largely runoff values in the 50 to 80% of normal range. A couple things to say about why those numbers are lower than the snowpack numbers. First and foremost, we did have some drier than normal soil moisture conditions across the region going into this winter season, which has a negative influence on runoff. And we had drier than normal conditions after typical peak snowpack season, which also has an influence on runoff. And then furthermore, the relationship between runoff and snowpack is not one-to-one. So you don't expect 80% of normal runoff if you get 80% of normal snowpack. It's typically lower, kind of like if you get 80% of your normal income in a month, you don't expect 80% of your normal spending money. You still got the same bills to pay. I think that's a good analogy for this situation. And then in terms of the long-term water supply situation, there are some reservoirs in the area that are still looking okay. Things vary remarkably based on the size of the reservoir and how it's managed. But if we look at Lake Powell and Lake Mead, They are storing record low levels right now since they were first filled. So this graphic is showing a time series with the black line of storage in Lake Powell in millions of acre feet going back to January of 2021. And the green range is actually what we expect in terms of the normal range for a year. The brown range is the bottom 10 percentile through 2020, with the bottom of the brown range being the previous record low. So we've been record low since about mid-April of last year. All right, just a couple slides on the outlook. This is a look at September through November 2022, or this fall. It was created August 18th, so these maps will actually be updated this week by the Climate Prediction Center. But we're seeing an increased chance of above normal temperatures across the southwest US, with a bullseye over Colorado. This is owing to a mix of La Nina conditions occurring for the third year in a row, which typically gives us drier, warmer conditions in fall, as well as long-term temperature trends, and in some instances, land surface interaction, or sorry, land atmosphere interaction type feedbacks. I could talk about that more later if we have time. This is a look at the precipitation outlook for the fall, where we're seeing an increased probability of below normal precipitation throughout much of the southwest US as well. You do see an area of equal chances in southern Arizona. That's where the monsoon season may continue to pay dividends, so we see less of a signal in that region. But then as we get into winter, so now we're looking at December, January, February of 2022 into 2023, and we see an increased chance of below normal precipitation across much of the southwest US, with equal chances as you get north of central Utah and central Colorado. And this is a very classic La Nina-like signal. So during a La Nina year, what that means is you have cold ocean temperature anomalies over the eastern equatorial Pacific off the coast of South America, and typically warmer ocean temperatures off the coast of the western equatorial Pacific over Indonesia. That all affects where the thunderstorms occur over the tropics, which has ripple effects all throughout the globe, semi-predictable ripple effects. And for the case of North America, we tend to see a high pressure system dominate off the coast of California, with the polar jet stream shifted north, oftentimes favoring above normal moisture in places like the Northern Rockies and the Great Lakes and Ohio River Valley. But for our region, it tends to lead to drier conditions, with that high pressure blocking moisture from entering the area. All right, so that's all I have, but just a couple takeaway points here. The Southwest has seen some drought recovery over the past several months, with an above average monsoonal season. And we even have some pockets of drought-free area on the US Drought Monitor map, following several good months of precipitation. However, long-term drought persists. We see this particularly in our stream flow volumes and our reservoir storage. So just the long-term conditions going back 3 to 5 water years are leading to some more scarce water availability type conditions. And then given La Nina is expected to continue, looks likely to continue, almost certainly will not see an El Nino in 2022, winter 2022-2023. The odds of a warmer than normal and drier than normal fall and a drier than normal winter are elevated. So even though uncertainty abounds with these seasonal forecasts, long-term drought probably I would favor it persisting. So that's all I have. Sorry to be the bearer of bad news. I've been kind of used to it in recent years, but that's all I've got. And if there's questions or comments, I'd certainly be happy to address those.
Thank you so much, Peter. We're going to hold questions till after Christine's talk. Christine, I just made you the presenter. So as soon as you're ready, go ahead. We can see your slides right now, so we're good.
Okay, great. Well, thanks, Joel, and thanks, Peter, for that update, and Joel for the opportunity to share some perspective from the Great Salt Lake. So just want to acknowledge our team. I'm from the Utah Water Science Center with the U.S. Geological Survey, and we have a whole team of folks here who routinely monitor various parameters on the lake in collaboration with the state of Utah, the Great Salt Lake Ecosystem Program, and the Division of Natural Resources. And I just wanted to start with kind of where we are on with Great Salt Lake levels. I'm sure many of you have heard that we've reached historic low yet again. And this is in relation to a record that we have at USGS going back to 1847. So let me see if I can get my laser pointer up. Here's that record and lake elevation in feet for the south arm of Great Salt Lake back to 1847. We can see, decadal fluctuations in lake level. And if we zoom in on the last 10 years or so, we can see these seasonal patterns of rising and falling lake levels in response to snowmelt runoff and then subsequent evaporation throughout the summer and fall. And this is kind of where we are now at historic lows. Zooming in on the last few years, as Peter kind of mentioned, we've had these kind of prolonged years of drought conditions, and that's just led to this consistent decline in Great Salt Lake levels, where we get a bump up in the spring, but it's really not quite enough to keep us high, and we see much more lake level fall in the summer and fall than we do lake level rise in the spring. So last October we broke a historic record. Actually, we broke it in July of 2021. We broke the historic record that had been set in 1963, so about 50 years ago, or well, I guess 60 years ago. And then and we broke that record in October of 2021. The record low then was 4190.2. And currently we're about a foot lower than that, so 4189.1. And given what we know about how this system behaves, and Peter just sharing his outlook for what the rest of, the next few months are going to look like, we expect the lake to keep dropping and to reach a new historic low in the fall, probably in October or November sometime. But what I was really asked to come and talk about today was this Great Salt Lake Hydra Mapper, which is a web-based tool that allows for Great Salt Lake data and information to be publicly available on the web. And this tool was developed by Toby Wellborn and Shannon Watermullen, who are geospatial analysts with the USGS out of the Texas and Oklahoma office. And a couple of us at the Utah Water Science Center kind of just helped shepherd along the process, making our data available and kind of coordinating with state entities and stakeholders to develop this tool. And really what we wanted to try and achieve with this was to just make information widely available to folks of all backgrounds. And we at the USGS, the Utah Water Science Center, we kind of keep a pulse on the lake with various data streams we have coming in. And we wanted to be able to share that with the public, and a number of stakeholders also expressed a need for that and wanting to know how the lake was doing day to day. And so I'll just start by acknowledging all of their efforts. We engaged with stakeholders from federal and state agencies from the very beginning, a number of NGOs and researchers from universities. There's a really robust Great Salt Lake community of folks who are trying to understand and find solutions for the lake as we enter these really low conditions. And so we just really want to acknowledge all of their efforts. They had great ideas and really, really good thoughts on how to make this information more accessible and more usable to a wide audience. And the tool that, in the end was developed was greatly enhanced by their input. And so we really appreciated them and their involvement. So as I mentioned, the Great Salt Lake community has been collecting data for a long time. So we at USGS have been collecting lake elevations, like I mentioned, back to 1847. We also routinely monitor water quality, stream flow volumes coming into the lake, so what's the water supply entering the system, as well as meteorological variables. And other agencies also monitor water quality and various types of wildlife and ecosystem metrics and sediment. And so there's a lot of information for Great Salt Lake. And we at the USGS, we tend to think, well, we have a really nice database. We have the National Water Information System, and you can go to our mapper and you can scroll to a site and access the data and download it. But the truth is, for a lot of people, especially people outside of the USGS, it's really not easy to access the data, to download it, to make sense of it. And there are meaningful gaps in the existing tools. folks may not know that data are there. They may not know how to get to our database and download it, or know what to do with it. And so that makes it really difficult for the general public to answer basic questions like, how is the Great Salt Lake doing? And should we be concerned about the current conditions out there? And so what we really wanted to do with this tool and this opportunity with this web-based platform was to turn Great Salt Lake data into something meaningful for a wider audience. And so the goal of the Great Salt Lake Hydra Mapper is to provide easy access to Great Salt Lake information. So we want to be able to visualize current conditions quickly. And so this is kind of a screenshot of our lake levels from our South Arm Saltair Boat Harbor. This is a gauge we have out there. We provide the opportunity for the public to scroll in on periods of interest. There's some interactive capacities, really hoping to have people start to be engaged with these data and start to kind of understand the lake a little more. We also wanted to provide an opportunity to understand what the current conditions mean for a variety of beneficial uses. And so that's kind of, this is a screenshot of us integrating an existing framework for Great Salt Lake resources and how different lake levels affect various resources. Are we in a condition where it's adverse for a resource, or are we in a condition where it's beneficial? And here are some key resources that we've included, such as wetlands, biology or wildlife, land use, recreation, economics, and safety. And we really want to engage a wide audience, anyone from scientists, general public, decision makers. So providing kind of an overview of where we are, what it means, but also providing the opportunity for folks who really want to dig into the details to be able to do that. And so the Hydra Mapper is kind of divided into three main components. The first being current conditions. The second is what we call a water dashboard, and that allows us to put the Great Salt Lake conditions into the context of its watershed. So what's happening in the watershed in terms of snow, soil moisture, and stream flow throughout the basin. And then the third component is this matrix, so integrating the current condition of lake level with the beneficial uses. And I thought at this point I would stop the presentation and then kind of just go to the Hydra Mapper itself. So are you still seeing this web page here, Joel?
Yes, we can see that.
Okay, great. So here's the Hydra Mapper. It is live. And when you go to the home page, here's what it looks like. So a user will see, here we're at the Hydra Mapper, gives a little information on, background of the Great Salt Lake, and then you're kind of given this menu of these three different components. So if we want to check salinity and lake levels in lakes, we can click on that and it'll take us to these interactive plots, which go back about a decade, looking at lake stage or lake level on the bottom and salinity on the top. Salinity is a very important water quality metric for the ecosystem, and it's something we keep tabs on regularly. So allowing the public to kind of scroll into the data, see where we are, and get to know the lake a little bit better and understand the current conditions. Another thing we can check are the current, if we go to current conditions related to water coming into the lake. Here's a map of the major surface water inflows entering the Great Salt Lake. And then we can scroll down and get some interactive plots that show the data itself. So here on this, we're kind of looking at conditions at the Bear River. So discharge at the Bear River near Corinne. We can see the daily value that we're experiencing now. We can see it in a historical context. So what was the central tendency or the median for the whole period of record? What's the minimum? What's the maximum? Really hoping that this will provide users an opportunity to see, okay, here's where we are and here's what that means in a historical context. And then also be able to see the seasonal fluctuations of those stream flow values. We're showing about the last 2 months. And then for most of the data, I think all of the data we provide, there's always links to the data source itself. So if folks really want to dig in and explore the whole period of record, they have easy access to do that. This page also has a lake stage, again, for both the South Arm and the North Arm. So folks of various users, if you're a mineral extractive industry, maybe you're more interested in the North Arm, that's what this gauged record would show. If you're a branch and harvest industry or interested in the ecosystem and the wildlife, maybe the South Arm is of more interest. So trying to provide as much information as we can to a broad base of interests. Okay, so scrolling back up, that's kind of our first major component, is just the current conditions. How's the lake doing? And then the second component is this water dashboard. So this again is putting Great Salt Lake conditions in the context of its watershed. And when you arrive to this page, this is an interactive map, so users can scroll in and out. Right now we're looking at USGS stream gauges in the Great Salt Lake Basin or watershed. So you can scroll in and say, okay, I'm interested in the Bear River near Corinne. You can identify the site, see the current conditions, and then get a little more information. If users are interested, really want to dig into the details, they can visit the site page and dig into the data even more. This color coding allows users to see, if I pull up the legend here, it allows users to see where we're at, kind of get a glance of where we're at in terms of, are we at normal or below normal, above normal? So these color codings allow you to do that. Various layers that this tool provides include stream flow, various water quality metrics, snow, which we're pretty excited about. So this is from our partners at NRCS, Natural Resources Conservation Service. In the winter when there is snow, we'll be able to share what the snow water equivalent values are. Right now we could look at soil moisture, so keep tabs on that and kind of get a sense of what we're anticipating going into another snow season. So those are some of the tools available here. If I go back to the home page, then we can navigate to this final component of the Hydra Mapper, which is kind of integrating our current condition with this matrix, is what we're calling it. And what was really neat about this, again, is that this part of the tool was really the idea of our stakeholder group, of all the folks saying, okay, data's great, but what does it actually mean, and what does it mean for where we are and for all these beneficial uses on the lake? And the state of Utah, the Division of Forestry, Fire, and State Lands had come up with this, what are we calling it? We're calling it, I think, a beneficial use matrix. Sorry, I'm forgetting the name at the moment. But in their Great Salt Lake Comprehensive Management Plan, they developed sort of this spectrum of for various kinds of beneficial uses on the lake, whether current lake conditions are adverse or are beneficial. And so with kind of a glance, we can see that for many of these uses, current conditions, the lake level is adverse for a number of uses. We can also click on each one of those beneficial uses, learn more about it, see where it exists on the lake, and then these also dig into much finer detail of if a user is interested in a specific wetland around the lake, the matrix provides information on whether the current condition we're at is favorable or not at this moment. So those are kind of the main features of the Hydra Mapper. We've been getting a lot of great feedback, on this tool, and our metric of success for this is that people are engaged and that they actually continue to make suggestions for how to improve it, make suggestions for how to show the data differently, or have ideas for additional data to include. And so that's kind of how we are gauging the success of this product, is just whether it's being used and if people are finding ways to make it better. And so this is something we've been very excited about, and we hope that it will continue to generate more interest in the lake. And that's really all I had, and I'm happy to take any questions if there are any.
Great, thank you so much, Christine. This is really interesting. We only have time for 2 questions, and so I have one question for you and one question for Peter.
Okay.
But for you, I'm curious about if you can share an example of who's using the mapper and how they're using it. I'd be really interested in that.
Sure. I mean, one key person who is using it is the Great Salt Lake coordinator, and she is a person at the state of Utah who is trying to coordinate all these different groups. She coordinates the media. She's keeping tabs on all these efforts that are trying to get water to the lake. And so she refers to this quite often. Obviously, she really helped develop it as well. And then I think also people have expressed that their students, like researchers and people at universities, that it's really helpful for their students to be able to kind of access and better understand Great Salt Lake. So we're hoping it's a tool for students as well as for the general public to do something similar, which is just kind of get more familiar with the lake, as well as to be able to track what's going on out there.
Excellent, thanks so much. And a question for Peter, and this is about the GRACE measurements. So the satellite measurements that were showing the soil moisture and groundwater. And the question is, do those data indicate short or long-term drought?
Yeah, that's a great question. So with the groundwater in particular, well, first off, the US Drought Monitor typically separates short and long-term drought impacts based on whether they're over or under 6 months. I think that the groundwater kind of straddles that, maybe goes a little bit more long-term, but for the sake of transparency, I've never done a correlation analysis between GRACE and precipitation or temperature at numerous timescales. That's just an anecdote based on how I've seen it perform in past droughts. Like, I remember the GRACE satellite indicator was one of the products you'd see all the time during the California mega drought last decade, where they had a number of dry years in a row starting in 2012. So I think that it does correlate pretty well with some longer term temperature and precipitation type indicators, but I don't know if it's, you know, a true long-term indicator or only a long-term indicator. I think it also would correlate decently with, say, 3 month or maybe even 6 month or maybe even 3 month precipitation.
Excellent, thank you. And thanks to everybody who's entered questions that we don't have the time to answer right now. We will try to reach out to you offline and answer your questions directly. I wanted to thank our two experts, Peter Goebel with the Colorado Climate Center and Christine Rumsey with the USGS Water Science Center, Utah Water Science Center, for joining us and sharing their knowledge today. And also thanks to Joel Lisenby for continuing to co-host these Southwest Drought briefings. These were recorded and they're on the drought.gov page /webinars. Our next Southwest Drought briefing will be held on October 11th at 1 p.m. Mountain Time. This concludes our Southwest Drought briefing for September. Thank you so much for joining us, and we'll see you in October.